There's not just one way to solve a problem at Blue Chip. We plan, build, and test until we find the most effective solution.
We strive to make ourselves and our clients more successful. We are driven to be the best.
We are driven to compete.
We are driven to partner.
We are driven to collaborate.
We are driven to deliver.
Hello, everyone. Thanks for taking the time today to join. My name is Joe Butkovic, and I'm going to be telling a story about a fictitious employee named Stanley and a fictitious company called Security Inc. But I assure you the concepts are very real. First, let's talk a little bit about Security Inc. Security Inc. installs and maintains access control surveillance systems for commercial customers. Oh, it didn't get to my slide there, sorry. For commercial customers. So this includes things like security cameras, badges and badge readers, doors with locking and unlocking hardware that communicates with the badge readers. If I went to a discussion about AI in the security industry, I would immediately think of machine learning mechanisms like facial recognition, tracking specific people or objects, indexing video metadata, then using that metadata to drive advanced insight. However, today we're going to be looking at it from a slightly different perspective. So, who is Stanley? Stanley is a SQL developer at Security Inc., and he's been tasked with creating a sales report for the director of sales. The report needs to contain information like sales revenue, sales leads, sales associate information. Even though this story is told through Stanley, this role can be played by a lot of different people. Really, anyone with a programming background and a willingness to learn, especially a willingness to learn. With that, a lot can be accomplished. So this is the first time that Stanley has been tasked with pulling sales lead data. He realizes that he needs to learn more about the process. At lunch that same day, Stanley pulls up a chair next to the CRM developer for the sales software. He learns that the data associated to leads is captured and held within that CRM system. Stanley inquired about the CRM software ingesting and managing leads. Through these discussions, he learns about the logic behind passing leads to sales associates. This is simply handing off leads to sales reps in a round robin order, a round robin fashion. And then a light goes off in Stanley's head. There has to be a better way to determine which sales associate should get which lead. It shouldn't be so random. You know, we say round robin has some type of order, but really at its heart, it's random. And then the CRM developer goes into discussing sources that leads come from. And almost in a joking tone, he tells Stanley that Security Inc. still gets 12% of their leads from those magazine bingo cards that you rip out of the magazine, you fill them out, and you mail them in. And then that bingo card is then taken by an ops associate, keyed in the information to the CRM system, and that's how that lead object is created. So then Stanley just can't get two things out of his head. And that's, how does the current system distribute leads to the sales reps, and then manually entering information from the bingo cards into the system? The important parts of the conversation end there, and then him and the CRM developer talk about how the Browns are so disappointing every year. So now let's take a little more visual representation at the current lead ingestion process. So there are three different sources for leads here. Security Inc. receives the filled out magazine bingo cards that I mentioned before in the mail. They have an ops associate that are tasked with opening the mail, that has the bingo cards, uploading an image of the card to the CRM system, and then keying information from that bingo card into the system. This is obviously a very manual process and is done through repeatable action. Another source for leads is the Security Inc. website. Thankfully, those leads are automatically populated within the CRM software. So there's no manual intervention with getting those leads into the software. As a third source, you can see the prospects call Security Inc. directly, where they can then discuss different products and services that they offer. The sales rep takes down the prospect's information and enters it into the CRM system, and then informs the prospect that they'll have a sales rep especially made for them contact with them soon. The data on the leads coming from all three sources are managed and updated within this CRM application. So Stanley knows this is the source for the data that he's interested in. And again, as you can see indicated by that cycle symbol within the CRM application and sales team, the leads are distributed to the sales associates in a round robin order. That part is very important here. So after thinking through all the new information that Stanley has gathered, he recognizes some problems. The current process of distributing leads is not data-driven, number one. What I mean by that is the process is not using any data around the lead itself or the sales reps to drive the distribution decision. In an ideal world, the lead distribution process would consider data from the lead, from active sales reps, and then make an informed decision in passing that lead along. Stanley also realizes that the bingo card ingestion process, even though it's executed as expected, it follows a repeatable manual flow. So even on its happy path or its typical execution, it's following these manual steps of having human intervention of keying information off of those cards. Neither of these really provide an effective scaling model. These are factors within a process that should be sought out in order to recognize solutions that can be improved through AI automation. So scaling, decisions that are being made that aren't data-driven. Those are two extremely important factors. So Stanley starts thinking about what Security Inc. needs in order to improve upon these problems. Security Inc. needs a solution that will use a data-driven model to inform the CRM distribution utility of who to pass the lead to, which sales rep. This model will need to be built on an accurate data set, obviously. Even though it's so obvious, I like saying it because a lot of people will just assume that their data is accurate, and you have to go through the different processes of determining accuracy of your data. And then once that's done, you can build a prediction that is accurate or hope to be accurate. So then the lead will be assigned through these data-driven metrics around the lead object itself. So lastly, Stanley wants to implement some type of OCR solution where he can convert the image to text and then use that text to launch an object into the CRM system. This is all fine and dandy, but how's he going to do it? Stanley realizes that creating an OCR engine on his own seems like a massive task. But he realizes that there are different cloud services that are now readily available, pay as you go, that you can call things like an OCR engine, where it'll translate image to text and return it to you in a data object format like JSON. So let's take a look at Stanley's proposed high-level solution. So as you can see at the top there, we have the prospect, and this guy is on the Security Inc. website. He's searching around, looking at different products, and then that data and information around that prospect enters into the CRM software. The future state that Stanley has in mind for this is once the lead and the data around the lead has entered the CRM software, it will then take in a looping order each sales rep that is active on the floor. It will tie the sales rep data with that lead data and hit the model that we've created, and the model will return a value between 0 and 1 that says, hey, I think that this lead is going to become a customer, or I don't think this lead is going to become a customer. And it will loop through each of the sales reps on the floor and give a prediction for each, at which point that lead distribution utility will take in that information and based on its logical ladder, pass out the lead to the sales associate. And what I mean by its logical ladder is, the model returning what the potential is for that lead becoming a customer is not the end all be all. A lot of sales organizations have different tiers for sales associates depending on their seniority, how long they've been with the company. Whereas a senior sales rep will get X amount of leads every day, whereas a more junior sales associate will only get Y. So hitting that model as a piece of information to then use that additional logic ladder to drive out that business logic that we're interested in. Okay. Oops, sorry, I'm lagging a little bit here. So how will Stanley build and train this model? So again, based on this historical data that we're collecting, and it's at the point in time in which the lead is about to be assigned a sales rep. So that's the point in time in which this historical data is collected for each of these data points. And the idea there is once we have the sales lead within our CRM application, we're going to take those data points that we've trained our model with and pass along the sales rep with that lead data, and then the model will return its decision. And so from a technical perspective, Stanley decides that he's going to build this within Python. He's going to use free Python packages to build a binary tree classification model. And the binary part is, will this lead turn into a customer, yes or no, 0 or 1? So that's the expected output from the model. And then when he calls the model, he's going to put it behind an Azure machine learning web service so that he can, call it many times or however frequently he wants, and the web service will automatically expand and based on volume and return the data as necessary. So now let's look at the data set. As things develop within Stanley's world, he realizes things that he would want to try to drive this model's decision making. But it's not always the case that you have all the data you want, right? So working with the data architects on the BI team, they come up with a large query that pulls the historical information that's available. And this historical lead data available that's written here is what Stanley is able to use. So the lead contact information, so basically who is the lead? Just so we can pretty much tie an ID to that lead. Otherwise, someone's first name isn't necessarily that important in determining if they're going to become a customer or not. The lead source, so how they entered into our system like we were talking about before. How long the lead was in our system, the number of times the lead has been contacted, the sales associate contact information, so again, that ID that we can tie to a sales rep that we can then use it to drive our model with our historical data. And then the prediction fact of, did the lead convert to a customer? So with our training of our model, we're going to include that point of, did the lead become a customer? And then as we're testing our model, we'll remove that and have the model predict it, just see how accurate our model is. And we'll get into that. But some items that were on our wish list, again, lead demographic data, things like the size of the company that's interested in our services, their revenue, size not only from people perspective, but also from size of the building, maybe number of access points. Another thing that would be on the wish list, which of course people are aware of, different services and things you can do to generate sentiment with interactions, but the sentiment of the interactions with the people that the lead has interacted with at Security Inc. So have they had generally positive interactions, negative interactions? And we could have built that into our model. And of course, many more. You can think of so many. So just to dig a little deep into the Python script and kind of go through the workflow there, once we have that data set that was pulled through the other key players and as data architects on the BI team, data engineers, and we got this data set. So within the Python script, we're going to import that data. We're going to follow all these steps that are necessary in order to build and train the binary classification decision tree model. Things like encoding, where we're taking character fields and converting them to an integer so we can transform them back and forth, fitting the data to the model. And then, of course, analyzing the fields that you have brought in. There are different free packages and features within Python where you can see, compare different variables or data points within your data set and see if there's any relationship between them. And then, of course, building and training the model and testing the model. And I just wanted to pull these 3 lines in here that I just clipped from the internet, searching create Python decision tree classification object. And with these 3 lines, as long as you have imported your, training set for your X train and then your prediction Y, it just takes this to build that classification model. And then you have this classification object that you can begin using in a real life setting and bouncing all these different calls off of. So the bingo cards, why does this need to be changed? So obviously through a lot of manual intervention and consistent repeatability in their process, there's a lot of room for improving the efficiency of this. Given that it's all manual, there's not much room for an appropriate scaling model. If we get more and more bingo cards because we're growing and we're attacking more areas of the country or the world, then we're going to have to hire more people to process those bingo cards, and that's just not an appropriate scaling model. So it's good to save on these operational costs, and then also saving up, freeing up the time of those ops associates so that they can focus on more higher value items. So how will Stanley do this? So he's going to use the Azure Computer Vision service to convert an image of the bingo card to text. What gets returned from the service is a JSON object that basically has information about the image itself, the metadata, and then the text that it pulled off of there. So once you have this converted text from an image, so what? What does that tell you? We really need to develop some custom logic to say, okay, if this text appears on this location on the page, we assume that that equals this object within our CRM system. And this customization is going to be done through Python. So just to get a quick visual on how the Azure Computer Vision service works, again, you can take images, whether it's like JPEG, PNG, that accepts a couple different formats. You pass that as a parameter to the service. The service extracts the text lines, words, and different metadata off of there. And then it returns bounding box information around each set of text. So if someone scans in a document and it's slightly tilted, this service will return, hey, the orientation of your document is 350 degrees. So you know it's slightly tilted. So what that means is if you scan in a document that's slightly tilted and you have some sort of template that you're saying, hey, if this data point is in this location, then it's X to us, right? But now that the document is oriented in a slanted fashion, those locations are off. So Stanley decides to use free packages within Python to manipulate the image to, upright it straight up and down based on the orientation information that's passed back from the service. So just to go again over the workflow for this type of Python script, we're going to send that bingo card to the Azure service. We'll get back that JSON object and we're going to transform it to transform the image so that we can reorient it, make sure it's completely up and down. And so that way we'll be able to interpret a clean image when we're pulling the information off of there. And then eventually through our custom Python code, assigning that interpreted text to the correct data objects within our software. Okay, so those are the two proof of concepts, right, that Stanley has developed. So through doing this, Stanley has sort of developed a bit of a vision, and the vision that he sees now is he wants to seek out processes and workflows that can be improved through AI automation. And this is what I referred to in the beginning of this talk about how we're approaching it from a slightly different perspective than, facial recognition, or if you think about, advanced analytics for insight into sales numbers. For instance, if we attack this territory, we can expect X in sales. That's more of a reporting up of information, but this machine learning mechanism is implemented right into the workflow or into the process itself. So it automates it intelligently. It's not just producing some type of report that gives you information. It's actually driving its decisions from the machine learning mechanism. So in order to really get this vision off the ground, you have to sell that vision to key stakeholders. So Stanley's proof of concepts affected top line and bottom line metrics. With improving the efficiency of sales by intelligently passing off those leads, he's going to affect that top line. And with making his ops ingestion of the bingo cards more efficient, that's really going to affect bottom line metrics. So Stanley knows it's important to identify both those and selling them. Also identifying the scaling model, because the assumption is if you're interested in these new technologies and everything, then you're going to be interested in growing and you're planning on growing. So you need to have these scaling models that are appropriate. With presenting these POCs to leadership and the different key stakeholders, you'll allow them to begin thinking with these possibilities in mind and bringing in other ideas. Yeah, that's a good idea. You know what that makes me think of is this thing over here, and start pulling in leadership thoughts into it. And then one of the most important selling points for me is the fact that you can do a trial period rather inexpensively. These cloud services are pay as you go for what you use. So you could spin up a trial period almost for free a lot of the times, because you'll have a certain amount of calls that you're allotted for free. So just to close it out here, and I know I'm pushing my time a little bit, but what did Stanley learn a year later, right? So he realized that he was thinking of the solution almost in a bubble, in a machine learning bubble, right? So he develops this engine that can predict these great things, but then how do we implement it within the solution itself? Well, it's going to be communicating with the CRM application and the distribution utility, right? So it'll be communicating back and forth with that. So you need a CRM developer and different people involved as well. So another question to ask at the beginning of these discussions is, what can be solved without intelligent automation? Well, one person might say, with the bingo cards, maybe we just figure out a way to make them fill those out digitally, give them a location to our website and they go fill it out. And then those fields that they fill out are automatically transferred to us, and we don't have to do OCR. And then finally, if I can make one last point, it's really not a matter of if with this type of technology and intelligent automation, it's a matter of when, because those companies that start to capitalize on these services and these capabilities are going to be, improving their efficiencies and all these other different aspects, and the ones who don't will get left behind. So now that's the end of what I got to say. I'll turn it over to Bill and Susan.
Okay, am I live right now? I'm Bill McHenry. I'm an associate professor at the University of Akron and teaching in our analytics program, and also very active in the site board. So Joe, the first question we'd like to put to you, and in a moment I'm going to introduce Susan Lowry, who is a principal consultant at Square One Consulting, and a site board advisory member. She's also going to be handling some of the Q&A today. So my first question is, you said that the solution is pay as you go, and that you could do a trial. It could be very inexpensive to begin with, but how do you plan for what is the ultimate cost when you scale it up? Because it seems to me like you could have unexpected large costs, especially when you're using a service like Azure. When you scale up, you're going to end up spending a lot more money than you think you are. And then how do you know that that's actually going to be paid back for in leads that will pay off?
Yeah, certainly. So the place where we'd be paying for an Azure service is within that OCR. And so I know just through using it that Azure offers 1,000 calls for $2. So if we imagine a ops associate going through and keying in 1,000 bingo cards, about how long would that take them? I don't know, a week or something, maybe a little bit more. And then multiplying that time by how much it costs to employ that person. And I think you'll find just right off the bat that the service is cheaper. Now, again, the reason that I bring in what did Stanley learn about defining that end-to-end solution is there might be other pieces that become cost factors outside of the engine decision-making piece, like upgrading the CRM application or buying a new distribution utility. For instance, an example of that would be in the Salesforce application, there's an omni-channel utility that provides the sales reps with a nice UI and it distributes the leads for them. So, it's important. And, the way you identify a cost up front would be to gather some data and put that data up against the cost of the number of calls. So if you have, 500 bingo cards as your frequency per week, then you know what you could expect to be spending per week from that service.
Okay, thank you very much. I'm going to let Susan ask one quick question and keep your answer short, and then we're going to
Okay.
move on to the next speaker. So here's Susan.
Thank you, Bill. Hello, everyone. I just have one quick question for you, and that is, you mentioned early on that anybody with a programming background can sort of partake in this kind of activity. And I'm just curious what sort of recommendation you have for additional training and/or certifications to prepare somebody to be able to, tackle a project like this.
Well, I'll let you guys in on a little secret. Stanley is me, basically, right? So don't have any certifications in data science or in machine learning. Everything is just my own personal interest. And, you can go on Google and type in create a binary classification model in Python, and you'll see 1,000 different articles of different ways to do it. So the free training is out there. You just have to have that willingness to learn. It's not the skill, it's the will.
Great, thank you. Very inspirational.
Thank you.
Thanks, everybody.